Hello, and welcome to this presentation measuring current harmonics with MXO series oscilloscopes. In this presentation, we'll show how to use an MXO series oscilloscope to make measurements of current harmonics. This presentation assumes a basic technical understanding of current harmonics. We'll provide a review on the next couple of slides, but please see the presentation Understanding Current Harmonics if you'd like more detailed information on this topic. There are two general categories of loads, linear and nonlinear. A linear load draws current such that the resulting current waveform is sinusoidal. This means that only a single peak will be seen in the frequency domain representation of this waveform. A nonlinear load causes the current waveform to become non-sinusoidal, and this creates harmonics, which appear at integer multiples of the fundamental frequency. Each of these harmonics has its own amplitude and phase. Generally speaking, the more nonlinear a load is, the greater the number of harmonics, and the greater the magnitude of harmonics, and in turn, the more distorted or less sinusoidal the current waveform becomes. Current harmonics are almost always undesirable because they can cause many issues, the most serious of which is that these harmonics can disturb other devices on the grid. Therefore, consumer and industrial devices must often comply to standards, such as EN or IEC 61032, Mil Standard 1399, etc., which define the maximum allowable harmonic levels. Current harmonics are most commonly measured using an oscilloscope and appropriate voltage and current probes, with results typically presented in both graphical and numeric format. In some cases, a scope may also support an automated test for verifying compliance to one or more harmonic standards. Current harmonics measurements are supported by all Rohde Schwarz MXO series oscilloscopes, but require the K31 power analysis software option. In addition, two probes are needed: a probe for measuring mains voltage, which is usually a differential voltage probe, and a probe for measuring the current, which in most cases is a clamp-on current probe. It's recommended that the probes be connected and configured for the expected voltage ranges before starting the power analysis application. Note too that for best results, the voltage and current probes should be de-skewed before making measurements. Please see the related presentation, Understanding Oscilloscopes D-Skew, for more information about de-skewing and how it's performed. To start the power analysis application on the MXO, choose Apps from the main MXO menu. Then select Power under the General tab. Remember that license option K31 must be installed in order to launch the power analysis application. Next, we need to add a power measurement, and this is done by pressing the Add button. Choose Harmonics from the list of available measurements, and then click Add at the bottom of the screen. Once the measurement has been added, click on the Harmonics measurement in order to configure the measurement parameters. The measurement configuration for harmonics measurements is very straightforward. First, select which channels are used for voltage and current. Next, specify the fundamental frequency. This is usually 50 or 60 Hz, but can be automatically detected in most cases. The standard being tested against is then selected. This can be EN 61032, Mil Standard 1399, or RTCA DO160. Normally, the standard defines which harmonics are to be displayed and measured, but this can also be manually set by the user if needed. And finally, the bar graph scale can be set to either linear or logarithmic units. Let's now look at some results. By default, the top left corner of the screen displays both the voltage and current waveforms. This can be useful as a quick visual check for the presence of harmonics. The less sinusoidal, or the more distorted the current waveform, the higher the expected levels of harmonics. Beneath this is displayed the harmonics in the form of a bar chart. The number of harmonics shown depends on the selected standard, and the standard-specific limits are indicated by red lines above each bar. On the right side of the screen are numerical results, which include total harmonic distortion, as well as per harmonic results in table form. This includes values such as frequency, magnitude, limit, margin, etc. Tapping on a bar in the bar graph will highlight the corresponding row in the numerical table. In the case where a harmonic exceeds the limit specified by the standard, the color of the bar will change from green to orange, as shown here. The status for each harmonic that exceeds the limit will also change to fail in the numerical results table, and the margin value will change to negative, showing the amount by which the limit was violated. These values can also be easily exported by going to Save Recall and then checking the box for power analysis results. The resulting file in CSV format will contain a header line of the recorded values, followed by one line of results per harmonic, similar to the way that results are presented in the table. Let's end with a brief summary. Current harmonics measurements on Rohde Schwarz MXO series oscilloscopes require the K31 power analysis software option, as well as a differential voltage probe and a current probe. The measurement procedure is very straightforward. Simply attach and configure the probes, then configure the measurement parameters. In most cases, the only parameters that require manual configuration are selecting the measurement standard and any non-default display options. The current harmonics measurement results are shown both graphically and numerically in the form of the voltage and current waveforms, total harmonic distortion, and per harmonic measured values. This concludes our presentation measuring current harmonics with MXO series oscilloscopes. If you'd like to learn more about harmonics, power measurements, or test and measurement solutions from Rohde & Schwarz, please see the links in the video description. Thanks for watching.